Hello, Al, and all the guys at Fox. Here is your brake booster that you sent in for me to repair. Unfortunately, ATE made we have an unknown number of defective brake boosters that require machine work inside the faceplate because the booster was not machined properly in the first place. And this booster, having been in service and then taken out of service because it leaked, had a lot of issues internally. You can see what's left of the rubber parts that were in here. I had to chip some of them out. They were so stuck inside. This is the vacuum check valve. It was stuck internally with rust and corrosion. The check valve inside behind the inside the faceplate was stuck as well. And there's a small passageway that leads directly to this bleed screw from the center of the faceplate, which is how brake fluid gets from here, activates the booster behind here, and then of course where you bleed it up here. And that passageway was stuck. The rubber cup on the slave cylinder in here this is the remains of that rubber cup. It was hard and was no longer going to function. The inside of the slave cylinder was rusty. I was able to hone it and get the rust out, fortunately. It had a little minor pitting left behind, but that was down at the base, not enough to affect anything. The main problem, of course, was weeping from this weep hole right here, which is your first line of defense in terms of knowing when the booster is failing. And that one obviously leaked right from the very beginning. Now the booster currently has brake fluid in it. I've tested it, and it's sitting here with brake fluid in it, and as you can see, it's not leaking. Now what we're going to do is test the booster. We've got vacuum. Both gauges will go up and read the amount of vacuum that my vacuum pump can produce, and then as the booster is activated, this gauge will stay stationary and this gauge will go down to zero. The more that the booster is activated, the more this goes to zero, and then when the booster is fully activated, that's at zero. Over here we've got the hydraulic portion input. These two gauges are tied together, so when this gauge goes up, it maxes out, and then this gauge goes and reads our final input pressure, which is a function of the master cylinder, or my lever right there. Output, both gauges tied together. This gauge goes up, maxes out, and this gauge reads final output pressure. And since this is a 2-to-1 boost ratio, whatever this reads, max here, this is going to read double. And so what we do is test the booster without vacuum, which also tests our gauges. We're 350 here and 350, a little over 300, 350, 400 here. So the gauges are as accurate as they're going to be for 50-year-old gauges. Now we're going to operate the booster. Oh, by the way, I am using DOT3 brake fluid, which is what these boosters are and the brake systems are designed to use. I don't know that you can't use silicone, but I don't recommend it. Fully activated. 350, between 600 and 900 on this one. Come over here, check the booster. You can see there's no leakage. Cycle it again. One time. Full activation. got a good booster. This little screw right here, this little screw is a test port. And if you want to test the booster while it's in the car, remove this and put your vacuum gauge in there, and you will get the reading that you're getting here, which is this gauge here going to 0. So that's this line right here. So the more you activate the booster in the car, the more this goes to 0 until it's fully at 0 and the booster is fully engaged. Now that's one test fitting that you can use there. Anyway, I'm going to leave this on here for a few hours, maybe overnight, make sure there's no issues. But at this point, with at least 350 psi in this chamber, I've got no leakage coming out of the booster. Thank you.